enzyme until they get the right protein. And that's what is the equivalent to the barriers between the glass bottles. So every cell, a liver cell or a kidney cell or a muscle cell, will have different enzymes activating particular chemical reactions. And the enzymic activity, the catalytic activity of a protein, is determined by its three-dimensional shape. And that's determined by the genes. So proteins have a very, very, very special role to play in earthly life. And we don't know whether there's anything else could do that. But you raised the question of whether there are some molecules that can play both roles, both the protein role of being a catalyst and the DNA role of being replicating information. And RNA, which is a rather similar chemical to DNA and which is much implicated in the transactions between DNA and protein, RNA does have, at least in rudimentary form, the catalytic, something like the same catalytic qualities as protein, and it also has something like the replication qualities of DNA. So the great hope of people in your field, now I'm telling you your own field, is that RNA might be the bridge, might solve the problem, the catch-22 problem, by being capable of both the DNA role, the replication, and the protein role, the catalytic role. So many of the modern theories of the origin of life center on RNA as the possible precursor.
Now these molecules are all, in effect, one-dimensional. As you say, the proteins roll up into three-dimensional shape, but everything starts out as digital information in one dimension. Could we imagine that life might do it in two dimensions? After all, the disk in my computer is a two-dimensional thing.
I think I could imagine a two-dimensional genome. What I can't imagine is a three-dimensional genome. That doesn't mean that it couldn't exist, but the point about one and two dimensions is that it's very easy to read out the information. In the case of one dimension, like DNA, it's like a tape passing through a reader, and that's exactly what you see. Actually, it's been translated into RNA by the time this happens. So the DNA is is transcribed into RNA, and then the RNA passes through a reader, just like a tape passing through a tape reader. Actually, the tape reader moves along the tape, but apart from that, it's the same. Now, a two-dimensional genome could work pretty well. I mean, you just imagine scanning across or reading it in some way. Three-dimensional, it's very hard to imagine, because how would you get a copy? How would you make a copy of a three-dimensional object? It's not easy to imagine. So protein works in a world of three dimensions, which I think more or less precisely why protein itself could never have been the self-replicating molecule. Two dimensions I could imagine.
Let's come on to talk about once that great first step is accomplished and life gets going. We're talking now about the possibility of weird life, the alternative forms of life, and we might find weird life on other planets. We don't know, because we don't know what the probability is, as you've said, that life will get going in the first place. But once it does get going, everybody wants to know, well, is there going to be intelligent life out there? And we're now faced with the same or a similar problem, that we find it very hard to put a figure to how likely it is that something like intelligence will evolve, given that life gets going. If you've got some sort of microbes, come back a few billion years later, will there be radio telescopes? Now, I know it's unfair because, again, I'm saying, do you have an intuition about this? Do you think that if there is life, say, throughout the galaxy, throughout the universe, that there are going to be many cases of intelligent life, or are you, like me, just prepared to say, well, maybe, maybe not?
Pretty much. I mean, we have one very, very weak piece of empirical evidence, which is that we've not yet been visited. So if intelligent life were really very, very common, then you might expect that not they themselves would be here, but their radio signals might have been picked up.
There's a so-called Fermi paradox.
Yes, Enrico Fermi, the great physicist, was once at lunch with two physicist colleagues, and he suddenly said, "Where is everybody?" And his colleagues, it seems, immediately knew what he meant, which is rather remarkable. He meant why haven't we received any visitation by presumably by radio waves? The universe is so vast that there could be islands of life dotted around the universe to a very large number. But yet, because the universe is so vast, it could be that each island remains in perpetual ignorance of its neighbors, which would be rather sad. When I was making the argument about the possibility that we are the only form of life, no, I think I'll stop there.
Well, but it does raise this really important point, and I don't know if there's a yes/no answer to this, but the essence of Darwinian evolution is that nature can't look ahead, can't anticipate, that it's exploring the space of possibilities, and what works at the time, and that's it. And so I think a lot of people have this notion that intelligence is such a wonderful idea that somehow nature would march towards it and sooner or later would discover it. And yet we have no reason to expect that. On the other hand, if in evolution, once nature does discover a good thing, it does tend to make more of the same. There is a sort of amplification factor, isn't there? Could we see intelligence as of that category, that you discover a little bit of it by accident and you think, well, that's really good, let's make more of it, and
well,
we're not the end product, but
yes, I mean, when it arises by natural selection, and it did, we know it arose at least once in our cells, it had to have been useful for the propagation of genes in the first place. I mean, there had to be some benefit in growing bigger and bigger brains. And so you've got to think of a way in which it's, in a mundane, utilitarian way, useful to begin with. Now, you said quite rightly that natural selection has no look-ahead capacity. It doesn't, you're never allowed in framing Darwinian arguments to say it would be a good thing because in the distant future, perhaps we can foresee that the species is going extinct. So let's all ration our selfish greed so as to stop the species going extinct. You're not allowed to make that kind of argument in the ordinary Darwinian context. And it may well be that many a species has gone extinct precisely because there was no look-ahead facility. But once you get a brain that's big enough to do that, then it is possible to look ahead. And I just remembered a lovely satirical remark by Sidney Brenner, the great molecular biologist, where he was castigating people who think of natural selection as looking ahead. He said, you can't imagine that life forms in the Cambrian era might have selected a particular chemical because it might come in handy in the Cretaceous. but I mean, you are right that once brains become big enough to look ahead, maybe natural selection in the ordinary sense wouldn't favor it, but technology can take over. You start making complicated machines, you start developing books and computers, and right. A whole new kind of evolution gets going.
But it just interests me as to whether or not we really could expect some fraction of other worlds that may have life on them, starting out with simple microbial life, some fraction that might have intelligence, and what that fraction might be, whether intelligence is one of those things that is such a good idea that it's really quite likely to be discovered time and again, or whether it's just a quirky little thing that happened on this planet, and we think it's important because, you know, that's our thing. We feel that that's the defining characteristic of humans. But as my friend Charlie Lineweaver likes to remind me, you know, elephants probably think having a long trunk is the supreme quality, and they would look back in evolution and see evidence for a directionality towards longer and longer.
Yes.
Whatever the plural of proboscis is.
Yes. I mean, we can look around. We've got a lot of information about life forms on this planet. And so it's an interesting exercise to make lists of those features which have evolved many times and those features which have evolved only once. And it's been calculated that eyes have evolved at least 40 times independently. So it looks as though there's plenty of pressure to evolve eyes. And you could say that eyes are likely to evolve maybe only on this planet, but quite likely on any planet where there's light and where you don't live in a perpetual fog or something of that sort. But intelligence and language, it seemingly have only evolved once. I mean, we can look around the different mammals and we see lots of examples of flying, of gliding, of digging, of swimming, of eyes, of ears, echolocation, but not intelligence, not language. So I think already we can say that